This van model is giving me an orgasmic rush. Look at these videos and you marvel where the AI has come. And this model is either just 1.3 billion or 14 billion. And look at the physical simulation, cinematic quality, and you just wonder what sort of time we are living in. Look at this quality. Look at this one. Look at all the details and nitty-gritty which this model is producing just on the basis of text or images. I already have shown you in this video a couple of hours ago as how to get it installed locally, the 1.3 billion model, and then produce videos from text with very good quality. In this video though, I'm going to show it to you as how you can install 14 billion parameter model locally, and then we will also generate videos from images. So this model comes in two variants, 1.3 billion parameter variant and 14 billion one, and I will also shortly explain the difference in a bit more detail. So for both models you can go with text to video, but for image to video you would need to use this 14 billion parameter model, and that is what we are going to do in this video after getting it installed locally. But before that, let's check out this model bit more in detail, especially from the architectural point of view, because I believe this model is going to shape the way we think about this AI video generation with text. So in front of you, this is something called as variational autoencoder. It's a new 3D causal VAE or V architecture as we call it, which has been specifically designed for video generation. So what they have done here is they have combined multiple strategies to improve spatio-temporal compression, reduce memory usage, and ensure temporal causality. These enhancements not only make their V more efficient and scalable, but also better suited for integration with diffusion-based generative models like diffusion transformer, and that is evident from a lot of videos which they have shared. And I have to reload this page, I'm sorry, because this is such a heavy page, but still you can see that the quality of videos is simply sublime. Look at this one. I'll just wait for it to load and run, and then look at this one. So this is what I was talking about. This is coming from V. Look at this, how realistic this one looks. Now let's try to get it installed, and while it gets installed I will be explaining it more so that we don't waste time. Before that, let me also give a huge shout out to Mast Compute, who are sponsoring the VM and GPU for this video. This is the VM I'm going to use, 1.2.1 and this is my GPU card, NVIDIA RTX A6000 with 48 GB of VRAM. So let's first create Coda environment, and while that's get created, let's check out a bit more videos. Look at this one. Hopefully it is going to show it to me. It is just loading, so let's wait. Okay, meanwhile we will have a look here. So it is controllable editing. Look at this. Wow, so you can even edit it quite nicely, but I'm not going to show you editing in this video. I will create another one because that requires a full-blown video. Okay, let's check out this one. Wow, so you can even do the visual text generation, and that is one thing which was missing from the from the previous models. Okay, let's go back meanwhile to see what is happening. Our environment is created. Let me also create a Coda environment here. CUDA installation, because I have NVIDIA's GPU. This is going to take a minute. So you see how good that looks. Especially look at this text on this video, and look at this mad racing on the right hand side. Pretty cool, isn't it? They also have shared the prompt. Maybe I will also try out this prompt. But this is a text one, so we will check out the image to video one. Look at this. This is a sound effect. I have turned it off. I'm not sure if YouTube would allow me, but you can switch it on because I will drop the link to it in video's description. Look at the concert. Okay, while that happens, let me also introduce you to the sponsors of the video, who are AgentBot. AgentBot lets you effortlessly deploy a personalized knowledge bot across platforms like Discord, Slack, and others. It is ideal for open source tech communities and startups that provide user support, and I will drop the link to their website in video's description. Okay, let's go check our terminal. And these prerequisites are done. Let me clear the screen and we will git clone the repo. And I'm git cloning the repo of it and seeding into it. Shouldn't take too long. That is done. Let's install all the requirements from the root of the repo. Primarily it installs the torch vision and takes around a couple of minutes. And while that happens, let's check out a bit more videos here. Look at this product feature. Again, this is a text to video one. And look at the quality. This is really quite inspiring, I would say. Wow, let me look at the Eiffel Tower. Yeah, look quite good. Okay, let's go here, check out this one. Again, sublime quality. Look at this one. Focus on the hands here. They are quite well formed. And then all the samples look pretty neat to me. Look at this smoke coming out of it. Okay, so I'm just going to close it and let's have a quick look on some of the other things which they have been mentioning here in this tech report. So if you look here, primarily what this is showing you is that the area of sphere represents the size of model parameter, and the default compression rate is 4 into 8 into 8. So this is showing that the performance is quite competitive across both metrics, whether it it is convolution module or it is any compression ratio. So the number of frames in each processing chunk is limited to at most 4, by the way, and that is preventing GPU memory overflow. So state of the art results here in this one. And then similarly, these are some of the other stuff which they have shared here. For example, this is around their video diffusion transformer, because this Wan2.1 is designed using the flow matching framework within the paradigm of mainstream diffusion transformer. And they are also utilizing T5 encoder to encode the input multi-language text that incorporates cross attention within each transformer block to embed the text into model structure. They have also employed a linear layer and CLU layer to process the input time embeddings. And then this is also shown here and here, where they are showing some of the theoretical versus actual speed up. And this is again the thing about the clip which I was discussing. And by the way, this MLP is shared across all their transformer blocks within, and with each block learning a distinct set of biases, and that really lifts up the whole quality of this model. And then similarly, they have shared some of the other data around the training and all that stuff. So for example, this is mainly around their training data set, as they have curated and deduplicated a candidate data set comprising 1.5 billion videos and 10 billion images sourced from both of their internal copyrighted sources and publicly accessible data. In the pre-training phase, their goal was to select high quality and diverse data from this expansive yet noisy data set to facilitate effective training. And throughout the data mining process, they have designed a 4-step data cleaning process, which you can see on the screen, focusing on fundamental dimensions, visual quality, and motion quality. Okay, so I hope that now you understand a bit more around its training and its architecture. Let's go to our terminal and see what is happening there. Okay, all the prerequisites are done, which is great. Now let me log into the Hugging Face. You would need your Hugging Face free read token, which you can obtain from your huggingface.co profile. So make sure that you have that, and we need it to download the model from Hugging Face. So I'm just putting in my token here, and then my login is successful. Next up, let's go to their Gradio folder and from there we need to run our image to video. And if you want to run the text to video, if you just ls here, you will see that they have shared scripts for all of it. So I'm just, because I have single GPU, so I'm just going to run this image to video 14 billion on single GPU. First it is going to download the model, and then it is going to launch our Gradio demo, hopefully. I'll be honest, I haven't really tested it yet. Okay, so it says that it couldn't find the checkpoint. So what it means is that I would need to specify the checkpoint, or I would first need to download it. That is not a problem. Let me quickly download that, because we are already logged in. So I'll just go to Hugging Face page and grab that model. So now, as we already are logged into Hugging Face, I'll just go to the root of the repo like this. Let me clear the screen. And then in order to download the model, I'm just going to use this Hugging Face CLI download, and it is going to download all the models. And there are, it seems, 7 shards of it. So let's wait for it to get downloaded, and then we will proceed further. And the model download is almost there. And all the models have been downloaded. Let me quickly show you the space on disk they are occupying. So around 77 gig, as you can see on the left. Maybe let me clear the screen and show you. There you go, 77 gig. So make sure that you have that much space. Okay, so now let's run our Gradio demo. And for that, I'm just going to run this command. So again, I'm calling that single GPU image to video with 14 billion, and I am specifying this parameter with my checkpoint directory, which is again the one where we have just downloaded the model. So let me run it, and it is running, and it is also downloading one remaining model, I believe. So let's wait for it. And the model is loaded and running on our local host at port 7860. Let me access it. And there you go. So our Wan2.1 is running the image to video with 14 billion parameter, and you can select the resolution from here, whether it is 720 pixel or 480. I'll just go with the 721 if it allows me to select. Okay, we'll try again. Maybe I'll just do the 480, what it does here. Okay, it is processing something. Anyway, I will let it process whatever it is doing. Maybe default is 720, and then you can upload your image here. You can define your prompt. I'll go with English, and then you can also do some prompt extension or enhancement with some of the shift, scale, and seed and all that stuff. I already have explained these parameters in this first video, and then you can generate the video here. Okay, so let's try it out. So I have selected this image of a bear, and then I have given it this prompt. I also enhanced it, by the way, by just clicking on prompt enhance, that a majestic brown bear stands in a shallow water. Its fur glistening with moisture and all that stuff. So it has done a pretty well vision. And then I'm not just going to put it any negative prompt here. I'm just going to click on generate video. And then let's quickly check the VRAM consumption too. I'll do it again. So it is consuming close to 17 gig of VRAM for this image to video model. Let's go up. Okay, let's wait for it to come back. It is taking a bit of a time to generate the video, so let's see how long does it take. And let's also check the VRAM consumption again. So it is consuming around 14 gig of VRAM in total, it seems. I'll just check it again to make sure. No, it is going up. I think this is the max I have seen so far, just under 19 gig. Nope, this time it has gone up. That's good that we are. Okay, so let's monitor it in real time. It is still going up, the full model, the 14 billion one. It seems it is loading, so I'll just wait for it a bit more, and then I'll keep checking. Okay, it is climbing up. Hopefully it will fit onto my GPU and doesn't time out, because my GPU is 48 GB. It has already reached to 36, 41. This is just like some match happening. Let's see. 46 now, maybe close to getting timed out, and it has already almost on the hilt of my GPU VRAM. It is not going up, it is consuming 48.5 GPU of VRAM, and it is still running. So it is because there is no more room there. I'll just close it. Let's see here, and you can see that it has gone out of memory. So in this case, what I'm going to do, I'm just going to switch over to another GPU and I will show you what happens there. Okay, so I have moved to the new GPU, which is A180GB, and I will also show you the VRAM consumption in a bit. I actually thought of just making a new video instead of carrying it on, but I thought, okay, maybe instead of editing it and showing you a very clean, crisp version, I'll show you my day-to-day life struggles with these sort of stuff. That it is not that in just one go you get these things right. So if you're struggling, don't worry, everyone goes through that. So you see what I have done here is, again, I have selected the image, prompt has been enhanced, and then I have just clicked on generate video, and it is currently generating the video. Now let's check out the VRAM consumption. So you see my VRAM is 80GB and it is totally consuming all of it at the moment, 80GB. Now if I take you to my terminal, you see it is generating the video, and even it is on totally on my 80GB VRAM. It is still taking just under an hour, so 57 minutes to generate that video, which we are generating at the moment. This is a majestic brown bear and all that stuff which we already saw there. So let's see. I will wait for it to generate the video and then we will check it out. I will wait for 1 hour. And at last it's done. Let's check out the video. It should be in the root of the repo. And there you go. So the image to video is ready. Let's play it in the video player. There you go. Not bad. The bear is dancing in the water. That is what we asked it to do. Let me play again. So bear looks good, and it's the same bear which was brown bear, and the water is bit changed, but other than that I think not bad at all. The bear limbs are also okay, and even the water is dripping. Look at the water motion, so the physics is right too. Pretty nice, very nice. And I'm not sure if we can increase the length of the video. I know that you guys are going to ask it, but you already saw that on even for this one 14 billion parameter one, it was consuming 80 GB and took an hour to get it generated. And just in case if you're wondering what happened to the Gradio one, so while it was running, it started giving me this error. So it crashed on me, maybe due to the VRAM, so I couldn't play the video in the Gradio, but it was there in the root of the repo. So I hope that this was helpful. Let me know how you go, and if you don't have that much VRAM, don't worry, just watch this video on your screen. So this is where I have shown you how to do the 1.3 billion one. You can't do the image to video with that, but text to video works fine. Check it out. Let me know how you go. If you like the content, please consider subscribing to the channel, and if you're already subscribed, please share it among your network, as that is the only marketing I do. Thank you very much.